Right, this is the full kit and caboodle you need for the original series Enterprise model kit that I'm making available to everybody. This board here, the one that's making the lights inside the nacelles, flash, and pulse the orange, that was previously made available. We're going to talk about the main board back here, and I'll go through the features first. I'll go through the feature. You can see what's happening right now. I'll just go what it does. You can see the running lights here. There's a green and the red, although they're kind of getting washed out in the video. That's blinking, I think 1.5 seconds on and half second off. And then you've got the strobes that go at the back of the secondary hull. They're 0.2 of a second, something like that. And then the main board also controls the speed of the motor. And this is how I'm doing my motor. I've got a motor inside that yellow foam. It's going to sit behind this cap because that's a Fallhaber motor and it's pretty darn quiet. But you can see the combination of the spinning domes and the lights. And then I've got a trim pot here, which makes it go faster, so you can set the speed to whatever you want, or slower. And I made this one is external. There's also one on the board. I'll go over that in a second. That lets you change the speed if you don't want to make. This is if you wanted to move it out to externally to the base or something like that. All right, so this board here, nothing really, again, I covered that previously, but this is what powers the pulsing amber lights and the blinking lights inside the nacelle. There's nothing really fancy about it. It gets fed 5 volts from this main board, so you can see that's what this wire is doing. The right angle header pins at the back, that's so that you can program it using the FTTI connector to a USB. And let's have a look at the main board. All right, so as we get in here, all these connectors down the side. The first one is for the power. This is connected to my 12 volt power supply. You can use 6 volt, 9 volt, 12 volt, whatever you want. It's regulated on board. The next one up that has the connector plugged into it is a 5 volt power that goes to the nacelles for the nacelle board. And then there's another one right next to it that would go to the other nacelle. Then these two at the top, they are the connectors for the motors. And it doesn't really matter how you wire up the motors. With DC motors, if you switch the wiring from plus to minus, they just spin in opposite directions. That's what we want, to switch the directions generally. However, you can change that depending on how you wire it up. If you wire it up accidentally, there's switches here at the bottom that let you change the direction of the motor. So that if you wire it up and you hook it all in, you think, it's not spinning the right way. There, you can see I just switched the direction. I'll do it again. So you can, once it's all wired up, don't worry, you can always change it. So that's what those connectors are for. This is the SN754110 half bridge motor controller. This is the 5 volt power supply. There's some diodes you can see next to the 5 volt power supply. That makes sure you don't hook up the power in reverse, which would blow everything, because I did that. And then there's also this 6 volt power supply here, which has a larger exposed ground planes that will be the heatsink for this, because it can get pretty warm. My motor runs at 6 volt. If motor you use is 9 volts, then I'd buy a 9 volt power supply, and then you can change the input to the motors with this switch up here. Right now it's set to 6 volts, because again, that's what my motor's running at, and that's what this voltage regulator does. But if you had a 9 volt motor, you can just flip this over here and it'll use whatever the incoming is. If you have a 12 volt motor, use a 12 volt wall wart, and then again, switch it over to V end for your motor, because that changes greatly how fast the motor will go. All right, over here, this is the onboard speed control. You switch between whether it's external, and that's what this connector is for. That's over to the right, or over to the left is this R1, and this is R1. So depending on how you want to do it, you can just switch that to control the speed. And then we've got the 2 connectors at this end, one for the running lights that go in the saucer, and one for the strobes that go in the secondary hull. Now, I always use headers anyway for IC chips, because you never know if you're going to blow a chip, or in the case of PICs and you need to reprogram it, you got to pull it out and program and put it back in. So I always use headers. In this case, in order to make the board as small as possible, because it is $5 a square inch to get these made. I'm using it on both sides, and again, you can see I have headers here for the Arduino board. So without the headers, you couldn't possibly have these overlap one another. You can see these sort of sit over top of one another. You couldn't have them overlap and solder them in. So the way you do it is you solder these headers in for the Arduino first, and the soldering points are on this side. They're underneath here. You can't really see it, but you will in the photos of the board. So solder in these headers for the Arduino, and then once that's done, you put in the IC header, and without the Arduino in it, you can get to the solder points on either side. And this, again, the Arduino has its own headers which allow it to come out. So I can show you. You can just pull that out. So if anything happens to your Arduino Pro Mini, you can always replace it or program it. It's better to probably program it off the board than on, because otherwise it'll try to power everything, including the lights and motor. So that's the board. Again, I tried to make it as small as possible so that it's about, when I did it through Osh Park, 3 boards were about $18 US, so $6 a board each. You only need one, unlike the Decels where you needed 2. But then, share it with your friends, who knows. The parts list is available in my Google Drive folder, as well as the schematic, and of course the Eagle boards, that you can just use that directly to get it made. So this does everything for the original Series Enterprise, the 1350 kit from Polar Lights, the most excellent model kit I've ever worked on. The only thing it doesn't do, of course, is the window lights, but those are just straight on lights. So if you're using the LED strips, those just connect to your incoming power, and away you go. So I didn't feel they needed anything special. All right, that's it.